I'm covering the moon. I'm the eclipse. Look out. Oh my goodness. No one, yeah, right. Oh. Turn around, right. Good afternoon, everyone. So let me introduce our speaker today. He is a graduate of Cornell University. JD Stillwater is a science ambassador and author who writes and speaks about profound insights from natural reality, insights that drive paradigm shifts and cultural awakening. This work springs from JD's love of science and his gift for making difficult concepts graspable for us non-scientists. After 24 years of teaching science and math in secondary classrooms, JD now shares the awe, wonder, and spiritual depth he experiences in what is being revealed by science. JD is married, as I mentioned, to Anne and has 2 grown children. So let's welcome JD Stillwater.
Thank you. I guess this is on. It's not too loud. Everybody can hear me well? Good. Okay. Well, good afternoon. I am so glad to be with you here today. And I want to begin with 2 quotes from a long time ago. Just to set the scene and to provide some context for what's coming on Monday. And the first is from a Greek poet named Archilochus. Anyone heard that name before? I had not until recently. He was born in 680 BC, and he wrote, quote, "Nothing can be surprising anymore or impossible or miraculous now that Zeus, father of the Olympians, has made night out of noonday, hiding the bright sunlight, and fear has come upon mankind. After this, men can believe anything, expect anything. Don't any of you be surprised," he wrote, "if in future land beasts change places with dolphins and go to live in their salty pastures and get to like the sounding waves of the sea more than the land, while the dolphins prefer the mountains." That's the end of the quote. And he was probably referring to a total solar eclipse that happened on April 6th in the year 648 BC. Here's another one from Herodotus, born a century and a half later, but still hundreds of years before our current way of doing years. He wrote, "There was war between the Lydians and the Medes 5 years. They were still warring with equal success when it chanced at an encounter which happened in the 6th year, that during the battle the day turned to night. Thales of Miletus had foretold this loss of daylight to the Ionians, fixing it within the year in which the change did indeed happen. So when the Lydians and the Medes saw the day turn to night, they ceased their fighting, and both were the more zealous to make peace." And Herodotus was almost certainly referring to the total solar eclipse of May 28 in the year 585 BC in Asia Minor. And yeah, the projector is going on and off, and I'm not sure why. I think we're just going to have to bear with it. Hopefully it'll be on more than off, because the visuals will help a lot. So he warned me. "Once you've seen one," he said, "you'll be chasing eclipses too for the rest of your life." That was astronomer Bob Noya in Harrisburg, Pennsylvania, at the Astronomical Society of Harrisburg in 2017. Some students and I were planning an epic field trip to Oregon to see the 2017 total solar eclipse. And the eclipse was a great draw for a field trip like this. It was kind of a perfect once-in-a-lifetime event to serve as the centerpiece of the trip's learning feast. But I have to admit, I was mostly looking forward to other things. Being present when kids saw the crystal clear desert sky at night. Watching their faces when they first saw Crater Lake's deep blue water. Stretching to hold hands around a redwood tree. Helping kids dig for real fossils in real cliffs. How many kids get to do that, right? I didn't really believe the eclipse would be all that special. I wasn't expecting a profoundly emotional experience. Now, you probably know that there are solar eclipses and lunar eclipses. The lunar eclipses are cool enough. That's when the moon is in the shadow of the earth. And they're fairly common. But on April 8th, this Monday, just a few days from now, there will be a total solar eclipse when a small part of the earth is in the shadow of the moon. That's a different thing altogether. It's a once-in-a-lifetime event. Now, it seems like we should have a lunar eclipse every time the moon is full and a solar eclipse every time the moon is new. But the moon's orbit around the earth is tilted relative to Earth's orbit around the sun, which is the blue line over there on the left. So most of the time, the shadows miss, like here. Here's the moon's shadow. It's not going to hit the earth, and the earth's shadow isn't hitting the moon. So when the orbits are like this, we can't even have an eclipse. Now, it's hard to explain this in 2 dimensions. So for a moment now, pretend that my head is the sun. I'm actually going to move over here. So pretend my head is the sun, right? And here's the earth. And the moon is orbiting the earth at an angle. It's up on this side and down on this side. You follow that? Okay. But the earth and the moon are also orbiting the sun. So if we fast forward 3 months, so now they're here. Now the moon is still orbiting at that same angle, right? But when it's over here, it can be on the backside of the earth from the sun. And when it's over here, it's possible for it to be in a direct line between the sun, my nose, and the earth. You see that? But that only happens under very precise, it has to be in exactly the right place at exactly the right time to cause a total solar eclipse. Kind of like this slide is showing. So now the tilt is like up in the back and down in the front. And sometimes the moon can be in exactly the right place to cause an eclipse. I want to share a video with you that NASA took of the moon's shadow crossing South America in 2020. So here it is. I'm going to let this run a few times. This is the moon's shadow, and here, of course, is South America. Let's run it again. Here's the daylight coming across the earth as the earth turns into the morning, and there's the moon's shadow crossing South America. You see that? Pretty cool. If you had been in that part of South America on that day, you would have experienced a total solar eclipse. And in just a couple days, NASA will be making new videos of the moon's shadow going right here, crossing this part of Ohio. So if we're outside, we'll be in the video. You can wave. Does anyone know what made this guy famous? Not just among physicists, but with everyone. What made average people all over the world regard Einstein as a genius? It was an eclipse. Yeah, it was an eclipse. You're right. E equals mc squared was his theory. He had published this crazy cockamamie theory based only on his own imagination. And one of the things the theory said is that gravity bends space, like a distortion of the space-time continuum, he called it. And this was really out there, kind of crazy, even for physicists. And he offered no proof at all, no evidence of any kind. But he presented this theory, his theory of general relativity, as though it had to be true. He was sure of it. And physicists at the time, they agreed with his math, but the implications of this theory were just a bridge too far. He must be missing something. Einstein said that when light from a star passes close to our sun, it gets bent by the sun's gravity so that stars we know are directly behind the sun, when we see them, if we could see them, would appear to be over there, somewhere else. Right? If only the sun weren't so blindingly bright. If only there was some way we could block out the sun for a few minutes to see if Einstein was right. Well, the total solar eclipse of 1919 confirmed that Einstein was right all along. And word spread really fast about the Jewish genius who changed physics forever just by using his imagination. Notably, it was a different implication of Einstein's theory of relativity that allowed the production of atomic weapons just a few decades later. But it's the same theory. Scientists are still testing theories and collecting data during eclipses. Next week, on Monday, hundreds of college students from all over the United States are going to be launching big helium balloons carrying scientific instruments as part of NASA's nationwide eclipse ballooning project. And those balloons will go above the clouds to collect data on temperature changes at various altitudes, changes in wind and wind speed, so-called gravity waves that I'll talk about in a minute, and other kinds of data. So eclipses are great for science. So in 2017, I went to Oregon with my students for a total solar eclipse. 7 years later, I still don't know how to describe it, but I'm going to try one more time. There was a feeling of anticipation when the moon first made contact with the sun's disk and then slowly began devouring it. It happened slowly, but it was fun to watch. It was exciting because it was the beginning of the main event for our field trip. It was finally happening. We noticed that in the dappled shade of trees were hundreds of crescent suns, the spaces between the leaves acting like living pinholes. I had also drilled a bunch of holes in a sheet of aluminum in the shape of the school's logo to demonstrate that same pinhole effect. Colanders work great for this too, like colanders for draining noodles. So when you go out on Monday, take along something white, like a sheet of paper or a white cutting board, and a colander or something with a hole in it so that you can project images of the crescent sun onto it. Over the next hour, the light around us gradually got dimmer and dimmer, and the whole world began to look thin, papery, almost two-dimensional. It was sort of like the opposite of an M.C. Escher drawing, where instead of a two-dimensional drawing appearing to have some depth, here was the real world's fullness getting crunched down, being flattened in a kind of unnerving way. And then it was dark. Not dark like midnight, though. The horizon around us looked like early dawn, but not just in the east. In every direction all around us, it looked like dawn. Stars twinkled clearly overhead. And we could see Mars and Venus. They became visible near this kind of ghostly hole where the sun had been. We saw Bailey's beads, these colorful dots of light around the rim of the moon, where the mountains and craters of the moon define its silhouette. It's not a perfect circle because there are mountains and craters. And this happens just seconds before it completely covers the sun. A handful of panicked birds flew silently but frantically across the campground where we were staying. And then the literal star of the show revealed these angel wings of wispy gray light streaming out from this sort of ominous black disk where the sun should have been and was just moments before. We remembered that during totality, we could take off our eclipse glasses safely and watch with our bare eyes. And I became intensely aware that this misty light I was seeing from the sun's corona, the sun's atmosphere, traced a laser straight line of connection from my eye up through our atmosphere, just skimming the edge of the moon, all the way out to the sun, in a way drawing me into their primordial dance, a dance that marries movement with stillness, light with shadow, and connects descendants with ancestors. But these were not thoughts in my head. I felt all of that, all at once. It was overwhelming. It was breathtaking. It was beautiful. And then it was over. 2 minutes is a painfully short time for a total eclipse of the sun. Far too soon, a sliver of sunlight ushered me back to Earth, to daytime in the Oregon desert. I exhaled and my breath caught, became a sob of joy and awe. Awe. Awe is a word that used to mean something like stop you in your tracks, see the face of God, jaw-dropping, eye-popping, breathtaking, earth-shakingly too wonderful to describe. Well, that describes my experience of the total eclipse of the sun. It was awesome in the original sense of the word awesome. Why? What is so special about seeing the moon block the sun? I don't really know. I can't explain it. I do have 3 thoughts, though, around that question. The first is that an eclipse shakes up our worldview. You know, the sun crosses the sky every day. It rises, crosses the sky, and sets. It just does. And we know that. We depend on it. We presume it. And then one day, weirdly, frighteningly, it goes dark for a while. Our ancestors who thought eclipses were foreboding portents of doom, well, they weren't just being foolish. The experience of totality is wildly unsettling, even when we know exactly what's happening and why, and we know for sure that everything's going to be okay. My second thought is that an eclipse connects us in an intimate, visceral way with the heavens. This is the essence of my work in science and interfaith spirituality, except that a book or a lecture has to get you there by way of the intellect, using words, describing what science has found, teasing out the aspects that invoke awe, and then striving to forge some visceral connection to them, and then maybe experiencing some spirituality of knowing that you're part of all this. An eclipse is a direct, immersive experience. It was a laser shot from the heavens straight to my soul until I was left gasping for breath and begging for more. It was unsettling and joyous both somehow. My third thought is there's a lot of new research, scientific research, about the experience of awe. Events like eclipses, with this combination of unfamiliar and really grand scale, can invoke what awe researchers refer to as the small prosocial self. Awe, the experience of awe, eclipses our egos. It takes us into a state of being where we feel the deep humility of our smallness combined with an expansive sense of interbeing with all existence. We become highly prone to feeling connected with others nearby, and also to generosity, a generosity of spirit. So awe makes us better people. The feelings that eclipses evoke in people have sparked religiously creative responses since the dawn of human language. So, for example, in Chinese legends, the sun is swallowed by a dragon. And to scare the dragon into spitting the sun back out, they would make a lot of noise, banging on pots and pans and drums and things like that. And of course, it always worked. Actually, much of what we know about past eclipses comes from meticulous records kept by Chinese scholars going back 4,000 years. So the science, today's science, some of it we owe to that cultural heritage. In India, a demon named Rahu is said to have disguised himself and slipped into a banquet of the gods. Vishnu caught him and cut off his head, just as Rahu had eaten, but not yet swallowed, a bite of the food of immortality. So they say an eclipse is Rahu's immortal head forever chasing the sun across the sky, and sometimes catching and eating it. But of course, because Rahu has no neck, the sun reappears when he swallows it. Some West African peoples believe the sun and moon take their cues from human behavior. So when humans let their anger and fighting get out of hand, the sun and moon begin to fight too, causing an eclipse. And humans have to teach peace to the sun and moon by ending our own conflicts, reconciling with old enemies, resolving grudges, and making amends, that sort of thing. That's my favorite. So what do astronomers say about eclipses? Well, fortunately, eclipses happen in regular cycles, which is how we can predict them so accurately. And astronomers call these Saros cycles. And that name, Saros, was coined by Edmund Halley of Halley's Comet fame. And he borrowed the term from the ancient Chaldeans, whose lunar calendar used that name, Saros, for a period of 222 lunar months, which makes about 18 and a half years, which is close to a Saros cycle, but not really. So what is a Saros cycle? When the sun, the moon, and the earth are lined up like they'll be this coming Monday, that same lineup won't happen again for one Saros, which is 6,585.321347 days long. That's about 18 years, 11 days, 7 hours, 43 minutes, 44.38 seconds later. Now, leap years mess these numbers down here up because the number of days in the 18 years varies due to the leap years. So this blue number of leftover days can vary a bit, but the other numbers stay the same because this number, this yellow number, is always the same. That's one Saros cycle. One Saros is the time it takes for the synodic month, the draconic month, and the anomalistic month to all line up again. Did you know there were different ways to define a month? Don't get too bogged down in these words and numbers. This will not be on the test. But I'll give you a minute to just look at that. The main takeaway here is that because the sun, the moon, and the earth are engaged in this really complex dance of orbits, eclipses don't happen every month, but more like every 18 years. All three of those, the moon's phase, its relation to Earth's orbit around the sun, and its distance from the Earth in its orbit, all of those have to line up perfectly for the eclipse to come round again, and that only happens every 18 or so years. For the mathematically inclined, I'm going to say a little more about those numbers. For those of you who hate math, just cover your ears for a minute. This will not be on the test, but it may help illustrate why eclipses are so rare. Mathematically, the length of a Saros cycle is the least common multiple of these three numbers. So for example, the least common multiple of 3 and 4 is 12, because you can divide 12 by both of them, right? But if you add a third number in, like 5, the least common multiple gets a little more complicated quickly. Does anyone know the least common multiple of 3, 4, and 5? 60, right. It's much higher than 12, so adding the 5 made it a little more complicated, a little higher number. So to illustrate how this relates to the three kinds of month, let's just pretend you have 3 digital clocks, each of which counts seconds. But the first one only counts to 3 seconds and then starts over. The second one counts to 4, and the third one counts to 5. If we start those clocks all at the same time, how long will it take for them all to synchronize back around again to 1 at the same time? What's that? They're right, but let's wait it out anyway. It'll give me a chance to hydrate a little bit. So they're kind of all over the map here, right? They seem totally uncoordinated, and they aren't for now. But just wait. Are there any math teachers in here? None? Oh, good. Okay, if I get this wrong, there'll be no detention for me. So they're just counting away, doing their thing, but not coordinated. They're all just a little bit staggered, not quite lined up. If we were right about the least common multiple thing, they should come back together at 60, right? There it is. Yay, it happened. All right. If, what's that?
You got an A.
I'll take it. What can I do for extra credit? No. If instead of counting to 3, 4, and 5, if our 3 clocks instead each counted to these numbers of days, that'd get complicated really quick, but it would take 6,585.321347 days, or 1 Saros cycle, to come back around to being in sync with each other. That's when we have another eclipse with the sun, moon, and earth all in the same places they will be on Monday afternoon. Okay, enough math. To me, the most interesting thing about Saros cycles is the not quite 8 hours left over after you count the days. Those leftover hours mean that when the next eclipse in the series happens, Earth will have turned about 8 hours farther in the day than the last time. So the eclipse will happen when the Earth has turned about 1/3 of the way further around its rotation. So see on this map how an eclipse that crossed Europe in 1999 happened again here in North America 1 Saros cycle later. This is the one in 2017. Same path, a whole lot of days, plus about 8 hours later, or about 1/3 of the way west around the Earth. There are other Saros cycles happening simultaneously. So when you look at maps of all the eclipses in any set number of years, it gets messy. There are other eclipses happening. And all those you see on this map with other shapes and colors, those are part of other different Saros cycles, different geometries. So the bottom line here, though, is if we could wait 3 Saros cycles, or about 54 years, next week's eclipse will come back around somewhere near here, 54 years from now. It'll be close to here, but it won't be on exactly the same path of totality because it's not exactly 8 hours. It was 7 hours, 44 minutes, something like that. Now, I turned 60 a couple weeks ago, so I probably don't have 54 years to wait for that. Some of the staff here might, maybe. However, we can also look back. Does anyone remember the eclipse? I think I got a slide up. No, this is right. Does anyone remember the eclipse of March 7, 1970? You do? Where were you? Virginia Beach.
Same.
Good place to be. Anyone else?
Virginia Beach.
Okay. That was 54 years ago. That was the same eclipse we're going to see on Monday. The last time it was three Saros cycles ago. Let's put it that way. And the path of totality went right up the East Coast. So Virginia Beach would have been a great place to be. An astronomer friend of mine who's about my age, he remembers that leading up to that day, Mr. Green Jeans on the Captain Kangaroo show told all the kids not to look at the sun that day because we didn't have eclipse glasses back then, at least not mass-produced ones, paper ones. Now, I was 6 years old in 1970, and my parents were a little bit nerdy, and I remember them helping us make pinhole projectors so we could see the crescent sun from our driveway in upstate New York. It wasn't total where we were, but we went out to look at the crescent sun. Like ancient people in China, India, and Africa, eclipses offer us some pretty fertile ground for symbolic interpretation. The moon's physical influence on us through tides and the weird correlation with menstrual cycles and baby turtles hatching on the beach. There's even reason to believe that tides are what allowed life from the oceans to gradually adapt to life on land. So the moon's influence here on Earth is profound. The moon is a powerful force on the Earth, both scientifically and symbolically. So the moon figures large in art and literature for a reason. It taps into primordial archetypes in all cultures with symbology related to dark, to night, secrecy, cycles, femininity, time and eternity, companionship, mystery, and shadows, the shadow side of life. So metaphorically and symbolically, an eclipse is the joining of the masculine and the feminine, or if you wish, the feminine covering the masculine temporarily. During a total solar eclipse, you find yourself literally in the shadow of the moon and symbolically in the shadow of the shadow. Now, speaking of masculine and feminine, that trip in 2017 put all of that symbology in a blender for Anne and me. We had both been excited about being in the path of totality years before the eclipse was due to happen. But Anne's school year started earlier than mine, so the timing was really close. We thought we might go south to see the eclipse in North Carolina and then hightail it back for her first day of work. But then when my students got excited about the eclipse and began planning and fundraising for the trip, lots of constraints and considerations came into play, including the choice of the Oregon desert, where we were pretty much guaranteed clear skies. Anne pushed back on that plan because she didn't want the school trip to eclipse our plans as a couple. I invited her to come along as an adult chaperone, but the timing simply didn't work. And before I knew it, I was deep into the planning of the school trip, too deep to back out. In the end, the school's eclipse trip eclipsed our plans to see the eclipse together. And funny as that sounds, Anne was pretty disappointed. Still, she participated as fully as she could. She walked around the streets of Harrisburg, Pennsylvania, loaning people her eclipse glasses so they could see the crescent sun. She pointed out the crescent suns on the ground next to trees. And it was clear she had fun, but it wasn't the same. And we weren't together as a couple. A nerdy couple, I admit, but romantic too sometimes. Suffice it to say that this time, on Monday, we will be together for the eclipse. There are some cool effects we'll be watching for, and you can too. You're so lucky to be right in the path of totality. Animals will exhibit odd behaviors. Birds may stop singing and go to sleep, or they may just act strangely, so watch for that. Owls might wake up and fly around, along with other nocturnal animals. You might see possums and raccoons and things. We're going to spread out a white sheet on the ground to see if we can spot gravity waves. Now, this is a misnomer because the so-called gravity waves that are associated with eclipses have nothing to do with gravity. Someone started calling them that long ago, and we're kind of stuck with it. There is another different phenomenon called gravity waves that are related to gravity, but those have nothing to do with eclipses. So it can be confusing. Anyhow, the poorly named gravity waves of eclipses have to do with temperatures in the upper atmosphere. As the moon's shadow moves across the land, temperatures in the upper atmosphere may change quickly, causing some turbulence. And as light passes through that, moving from warmer air to cooler air, it bends or refracts, and it makes faint wavy shadows on the ground, kind of like you're seeing on the screen. And this is similar to a mirage. Different temperatures of air make a kind of waviness in the light that's passing through. And if we're really lucky, we may see ripples like this across our white sheet, almost like shadowy ripples on an invisible pond. It's subtle and it's easy to miss. And those are what people call gravity waves, and they are pretty rare. I saw them in Oregon in 2017, and hopefully we'll get lucky and see them here in Ohio next week. So if you can, lay out a white sheet on the ground and just check on it during the hours just before and after totality. Another thing we're going to look for is the Purkinje effect. Our eyes usually adapt as day slowly turns to night, and cells in the retinas of our eyes that respond well to colors are called cone cells, and they require bright light to work well. But when cone cells aren't getting enough light to work well, our brains and our eyes switch to using cells that work better in dim light, called rod cells. And rod cells don't see colors very well, but they can make out a little bit of green and blue, but not red. They're not good at red. So during an eclipse, the dimming, the gradual dimming, takes longer than it does in normal twilight. So there's a period of a few minutes before totality when we're in between using cones and switching over to rods. And during those few minutes, you may notice that green objects, green clothing, seem especially bright. The green seems to pop out, while the red objects may seem dim, almost grayish. And this is called the Purkinje effect. You're more likely to see it if you're wearing lots of bright red and green clothing on that afternoon. So bring out your ugliest Christmas sweater that has all the red and green on it. Looks like it might be cold enough for Christmas sweaters too. I mentioned Bailey's beads. Those happen because the moon's surface has craters and mountains that let these colorful shafts of light through from the sun's surface just in the moments before the moon completely covers the sun. I know this is an unusual spelling of Bailey's, but it's correct. That's what they're called. During totality, we should see Mercury and Venus, not like this, of course. These are through a telescope. But those planets are always fairly close to the sun, so most of the time we only see them just before dawn or just after sunset. But Monday is a chance to see them in the middle of the afternoon. We may see other planets too. Just after totality, when the sun breaks through on the other side of the moon, you'll see what eclipse chasers call the diamond ring. And these photos of the diamond ring are pretty spectacular, but wait until you see it with your own eyes. It is so beautiful. Many people have pointed out how peculiar it is that the distances to the moon and sun are in precisely the same ratio as their diameters, so that the relatively tiny moon appears to be just about exactly the same size in the sky as the unimaginably colossal sun, just right to perfectly cover it, exactly revealing the sun's atmosphere, no more and no less. And in 2017, I thought that was a pretty amazing coincidence. But then last October's annular eclipse reminded me, that was in the American Southwest, reminded me that the moon's distance from us varies. Its orbit is not a perfect circle, it's an ellipse. So when it's at a farther point, there's the annular, when it's at a farther point in its orbit, it looks about 12% smaller, just because it's further away from us. So when an eclipse happens then, it only covers the middle of the sun, leaving a bright ring, sometimes called a ring of fire eclipse, because it's too small in the sky to cover the sun. Still, the perfect geometry of a total solar eclipse is part of the appeal. It adds some extra magic to the experience of totality. Not only are eclipses rare, don't-miss events, but this is a special time in Earth's history too. The moon is steadily moving away from the Earth, about 1.5 inches a year, which is about as fast as your fingernails grow. Now, you know that tides are caused by the moon, but you might not know that the Earth's crust is also bent and distorted by those same tidal gravitational forces. It's a lot of friction. I understand there was an earthquake in New Jersey. So there's constant motion in the Earth's crust, and there's just so much friction. And that friction actually slows down the Earth's rate of turning. So the moon has to speed up in order to conserve the total angular momentum of the Earth and moon together. And that causes the moon's orbit to get a little bit wider each year. Now, 1.5 inches a year doesn't sound like very much when the moon is over 200, oh, I missed a slide. Here we are. The moon is really far away. You know, if you had to walk there, it would take a while. And so 1.5 inches, it's not much. But the day will come when there are no more total eclipses. The moon will be so far away that it will be too small to completely cover the sun. And all eclipses after that will be annular ring of fire eclipses. That'll be in about 600 million years. But still, we are blessed to be alive now, when the sky still offers this awesome show of a total solar eclipse. A few notes about safety. If you want to look directly at the sun before and after totality, you need eclipse glasses. I'm going to wait for this projector to catch up. You have to have eclipse glasses and make sure they are ISO certified safe. There are lots of fakes for sale online now. So if you have relatives, children, grandchildren coming to visit, check the glasses that they have. Make sure they're ISO certified. And I understand that Ohio Living already has good quality ones for you to use. Be especially careful with children on Monday, because as the eclipse happens, the sun will gradually get dim enough that it won't be painful to look right at it, but it can still cause permanent damage to your eyes, and children don't know that part of it. They're likely to look at it. The New York Times published an article on March 20 about people whose eyesight suffered permanent damage during the 2017 eclipse here in this country. One woman had eclipse glasses, but she looked at the crescent sun for just about 6 seconds. 6 seconds. She said she had a crescent-shaped hole, like a crescent-shaped problem with her vision, a spot, a black spot. And her ophthalmologist could see a crescent-shaped scar on her retina. And here it is 7 years later, and her vision still isn't right. So be safe. Wear those glasses right up until totality. It's also safe to use a pinhole projector, as shown here. And, I can show you how to make those. Actually, I'm going to in just a minute. Right now, look at that. If I knew my notes, this wouldn't be happening. Yeah, a pinhole projector. They're really pretty easy to make. You can use a cereal box or an Amazon box, whatever. You get a box, and you cut a hole in one end. You cover the hole with a piece of aluminum foil, and then poke a small hole in the middle of it. That's your projector. Now, stick a piece of white paper on the opposite end of the box on the inside. That's your projection screen. And then cut one more hole in the box for you to look through, and voila, your own personal eclipse theater. The longer the box is, now here you are looking in at that screen you made. The longer the box is, the bigger the image of the sun will be, but it will also be dimmer. So your choices are small and bright, or big and dim, or somewhere in between. But a shoebox works just fine. As I mentioned earlier, you can also bring a colander. It does the same thing. The holes of a colander are usually a little bigger than a pinhole, so the image won't be quite as sharp. But you'll see the crescent sun, and it works just fine. One more note about safety. In 2017, there was a bit of a ruckus in our campground. Someone wearing her eclipse glasses looked at the sun with binoculars. Now, this might seem like a perfectly reasonable thing to do. She's got her eclipse glasses on. But anyone who has ever used a magnifying glass to torture ants or start a fire can guess what happened. Her eclipse glasses burst into flame on her face, and she spent the eclipse in the emergency room. You have to cover the front lenses of any magnifiers you use. You can also look through welding glass if you happen to have welding glass laying around, as long as it's number 12 or darker. During those brief minutes of totality, you're going to get a little between 3 and 4 minutes, I think, here. During that time, you can remove your eclipse glasses because the sun is completely blocked by the moon, including all the harmful ultraviolet rays. Which reminds me, don't forget sunscreen on Monday as well, especially your face, because you're going to spend the afternoon facing the sun, right? Total solar eclipses are rare. When they happen, the moon's shadow traces a very narrow path across the surface of the Earth. The last time the path of a total solar eclipse passed over Willoughby, Ohio, was June 16, 1806. It was a Monday. The next time it will be here is in the year 2044, 420 years from now. So hopefully it'll be clear. I'll say more about that in a minute. But, don't stay indoors that afternoon. Get out and see it. Your next chance to see a total solar eclipse anywhere in the lower 48 states is in 20 years. And that one is mostly in Canada, with the moon's shadow just grazing corners of Montana and North Dakota. Pretty far away from here. Remember, though, if it's cloudy on Monday, we might not see anything. So I think even if it's cloudy all morning, go outside anyway, because you might catch a break, and it's worth waiting for. This exact thing happened to my sister-in-law with the annular eclipse last October. The clouds cleared up for her just at the right time for her to see the eclipse. So hopefully we'll have clear skies on Monday. All right, just to briefly review before the real-life test on Monday. A total solar eclipse is a rare treat when the sun, the moon, and the earth are perfectly aligned, and the moon is at just the right distance for the moon's shadow to trace a very thin path of totality on Earth's surface. And this one is happening right here in Willoughby on Monday. Make sure you protect your eyes from the sun's harmful rays. Remember that there's a lot of math behind this amazing event, as well as a lot of history, mythology, and symbology. Watch for some interesting things to happen during the eclipse. You might feel some strong positive emotions. Most of all, don't miss it. Being in the path of totality for a solar eclipse was one of the most profound experiences of my life. Monday is truly a once-in-a-lifetime opportunity to participate in one of the most engaging and connective astronomical dramas known to humanity. He warned me, and now I'm warning you. You're going to want to see it again. So free up the afternoon on Monday. Get outside, watch the sun get eaten by a dragon or a demon, or better yet, to watch the sun and the moon make peace with each other. May we all take all opportunities to make peace ourselves. One last personal note, and this is mostly to myself, and maybe it'll resonate for you too. I don't want to wait for something as spectacular as an eclipse to remember to just look up now and then. I want to remember the big picture that I exist in, remembering my place, remembering that I dance to the music of the spheres from my place on a sphere, embracing both the shadows and the light. I want my life to encompass both, eclipsed or bright, and when invitations come along to be reminded of my place in this world, like a total solar eclipse, I want to say yes to them with appreciation and with joy, with gratitude. Thanks for being such a great audience. I'm really grateful to Mary Ellen for inviting me to speak today. It was good fun. What time is it? Do we have time for some questions? It may take a second.
Hello, hello. Do your job. Hello?
There it goes.
Somebody's got to yell at it. What an astounding, and please, another round of applause. My goodness. Before we have some questions, because I'm sure we have maybe a few here and there, and remember, we need to speak into the microphone for the question so everyone can hear. We do have some amazing Eclipse cookies that were made by our culinary department, and some purple sparkle punch, because why not have galaxy punch on a day like today? The glitter is edible, don't worry. I drink it all the time. Maybe that's why I am the way I am. But yes, and then Kirsten will hand out your glasses as you leave, so that you each get a pair, those of you that need them. And thank you so much. So let's have some questions, shall we? Oh, right here.
Is there a safe way to take a picture of the eclipse, like with your phone or something like that?
Yes, although safe for who?
Right.
If your camera is pointed at the sun and you're looking at the screen of the camera, you're safe. Your eyes are safe because the screen can't make ultraviolet rays.
Right.
However, the chances of you moving the camera out from between you and the sun are good. I'm not sure about cameras. I would hesitate to do that because the little CCD, the thing in the camera that picks up the light and turns it into code, is probably damaged by ultraviolet. I'm not sure of that, but I bought a special, basically it's like Eclipse glasses for my camera to put on the front side.
You have a question?
But your phone's camera is small enough that I'm not sure, if you have extra Eclipse glasses, you could put yours on and then take an extra pair and put it in front of your camera while you do that. That should work.
Okay, could you cut like the film and tape it on the front of the...
The question is, could you remove the film from the Eclipse glasses and tape it on your camera or your phone's aperture? I think so, but be careful because if you scratch that film, it's not going to work.
In the mid-50s, it was October 1st. I was in the Philippine Islands in the summer. I didn't go and check that out.
I didn't hear the whole question. You were in the Philippines and there was an eclipse? Were you serving then?
I think I saw a total, and I wonder if there's some place where I can check that out online.
Oh, yes. Especially now. There are lots and lots of eclipse-oriented sites, and you can look up past eclipses. If you go to NASA's eclipse site, like how I knew when the last time there was an eclipse here in Willoughby and when the next time will be, there's a calculator that NASA has, and you put in the city, and then pick a button. I'm giving you too much detail, but go to NASA at their eclipse site and look for eclipse calculator, and then you can put in the city, and you'll find out when it was and even what time and how long it lasted, all kinds of facts.
Does it get as dark as the night or as dark as the cloudy day?
Much darker than a cloudy day. Dark like night. It'll be dark. The street lights will come on. Assuming you have the kind that, come on when it's dark out.
I got a question back here. I'm getting my exercise. Come to the other side of the room. I'm coming. I move as fast as I can.
I heard that some place they're setting off rockets, I think in Virginia, during the eclipse. Why would they do that?
That I don't know unless it's related to the balloon project somehow. There may be data that they want to collect that's just beyond the atmosphere, and you need a rocket to do that. So I have not heard of that. But it doesn't actually surprise me very much. I know that there are some airlines that were offering to fly the path of the eclipse so that you could get maybe an hour of totality. So they would stay in the moon's shadow. And that sounds like a really cool idea, but imagine yourself in an airplane seat, even if you were on the window seat, trying to look up out the window. To me, it sounds gimmicky.
Just a quick, that only lasts for 7 minutes with a very, very fast jet.
The moon's shadow is just moving too fast across the land. He pointed out that even in those flights, you still only get about 7 minutes of totality because commercial airlines are just not fast enough to keep up with the moon's shadow. Thank you. That's a great point. So gimmicky and doesn't really work.
You mentioned the moon is moving away.
Yes.
That in billions of years there will no longer be total eclipses. So looking at the other side of that, when the moon was closer, they weren't total eclipses, they were more than total eclipses, so the moon was obscuring the sun more billions of years ago?
Yes, and I'm sorry, did everybody hear the question? If the moon if its orbit is expanding and it's getting further away, that implies that millions of years ago it was closer and eclipses were more total. And yes, they would have been, they were, and totality would have lasted longer. I think this kind of image probably would be pretty much the same if you had been here millions of years ago, because the sun's atmosphere is so big. This black circle would have just been a little bit bigger, but you still would have seen the corona, those angel wings, as I call them. Great question. Kind of ironic that now that I'm done, the picture is not, it's not going anywhere.
This man talked about England and Africa. Christopher Columbus did a similar thing on the moon. He was, I think, in Jamaica, and they were getting hostile. He told them, if you don't leave me alone, I'm going to make the moon disappear. And there was an eclipse, and so he got by.
Interesting, so yeah.
You knew it was coming, huh? Any more questions? All right. How about one more round of applause? Thank you so much.
You're welcome.
This was way better than me doing this in videos. So, oh yes, and JD does have a book and some other things for sale in the back if you'd like to look at those. Please take a cookie and some Galaxy Punch, and you can get your glasses on the way out. The big star of the show, though, is going to be the eclipse on Monday. So, all right, everyone, thank you so much for being here today. Yes,
Yeah,
you can sign up for JD's newsletter as well.
I produce a monthly newsletter of science news, and people love it, and you can sign up back there. Thanks, everybody.
Thank you.